All right, talking unit circle today. Talking unit circle. You know what I'm saying? You can follow along. I know that y'all doing y'all thing right here in class. You can catch it right now or just catch this on the replay. Give me some time to get through it. I might make a few errors as we go through this because I'm refreshing it. It's been a minute.
Okay.
No. Y'all good. Just keep the volume down a little bit. You can catch it on the replay. So, with the unit circle, what you'll see is the first thing that you got to understand, you got to learn that we're going to split this thing in two. So remember, if I was to cut this in half, this will be 180, correct? And then this is the other side would be 180.
360 degrees.
Yeah, it's 360 total. So just think, that's how I chop this up in half. All right, so we got this thing that we're talking about where you're going to be using, it's called degrees and it's called radians. You know degrees are measured in, you know, with the degree symbol, but the radian symbol you're familiar with, it's a pi symbol, all right? And you'll be able to find that on your calculator by using the pi. So you're going to be able to use this radian degrees. When you're filling out the unit circle as an introduction, what you'll need to do is go ahead and label everything. The points, as you can see on this side, this point here, this is your x value, and this is your y value. This point here would be 1, 0. You can understand that, right? I'll rock with you, Rebecca. You with me? All right? And then this point here would be 0, 1. This point here would be -1 and 0. And then down here below, you have 0 and -1. So what you'll see with the unit circle rule, Rebecca, is that it's the length of this entire unit. One unit is its measurement on the x-axis is only one length on the x-axis.
I think we did something at the beginning of the year. We went to plot it.
Close.
Yeah.
Yeah, we're gonna get there. But this is the length is 1. All right. So in other words, the length of every unit circle here is 1. Because when we go inside here, you're going to see that the radius is also 1. The radius and the length is all equal.
Wait, it's always 1? The value never changes?
Yeah, this value. This here, x will be 1, 0. It's measurements, the increments, everything is in 1. There's only one slot. There's not 2, 0, 3, 0. There's not 4, 0. It's all 1. So this is all from the tab of 1.
So this is the unit circle and everything?
Yup, this is it. And this is measured, like if I had, what I mean by 1, meaning you're only right here. You're only right here, right here.
So you just have to memorize this?
Yeah, it's simple. But this is where at. Meaning like this is 2, 3, 4. This is 1.
Oh, so
1.
So it can increase. It could be like the 2.
Well, no, I'm just letting you know where we at. We're within the first increment. So we're only within. This is 0. That's 1. 1, -1, -1. That's as far as we're going.
Yeah.
All right, cool. So, breaking this down on the inside, right here, you'll have, we're about to start bringing in that, remember we did the trigonometry. This is where we're going to tie both of them together. SOHCAHTOA. Watch how we tie all this in together. When you have this here, you have this line here, right? And we're going to call this line that's on the inside of the circle. This is your longest side. We're going to, on the outside.
That's the diameter?
Well, no. A unit circle, let me tell you how this works. First, it goes counterclockwise. So it goes this way.
Okay.
This way. This way. We're going this way all the time. All right? We're going counterclockwise. Not like a regular clock. So, think about it. If you're going counterclockwise, you're opening up. The side that you're using to open up, that's this green line right here. This is called your terminal side.
Oh, I haven't learned that.
Think about it. It's almost like it's like this. Roof is closed, and then I open it. I'm opening it. I'm opening it. You see how this is the green line. It's really right here, and I'm opening it.
You're opening it from right to left all the
This
way.
way, right to left, yes. And the side, this side here, it's always the terminal side that you're opening that's going counterclockwise.
So terminal refers to the counterclockwise direction?
Terminal side goes counterclockwise.
So the terminal would be like
This is the terminal. This is for right now. This is your terminal. But it started here and we opened it like
What
this.
happens to the terminals on the other side?
It can go on the other side, but it's gonna be a value. So once we get there, let's just start here. So think about it, right? If the length of everything is 1, this terminal side, what do you think the length of the terminal side is?
1, 0.
You're genius. It's only 1. The length of the terminal.
Or 0, 1, I mean.
No, it's length. The length. I asked how long is this?
Oh, wait.
Like how long is this point on the terminal side from here
Oh,
to a
it's not a
point
coordinate?
on the circle?
It's just a
From the
unit?
center of the origin to a point on a unicircle, the length is 1.
Oh.
It's distance.
But what is it measured in?
It's in degrees and radians is what we're gonna get there.
Oh.
So it's just 1. It's all 1. You're only 1 increment. Right? So now we have this thing. Let's say I pick a point on a unicircle. Let's say I got a point here on a unicircle. You see it? You pick the regular point. When you're lining up the unicircle, you know that they're measured. The A will really be X and the B will be Y. You're gonna see what this means in a second.
You wrote A and B.
So A is really the X value, B is really the Y value.
Okay, so
What's the terminal?
Terminal side is just, that's the side on inside of the unicircle that opens up. That's what's actually going kind of, think about a clock. The terminal is the arm that opens up. It can only go this way, this way, this way.
But what
So
happens?
it starts like this. It's at zero, it's not open. Now it's opening up as you are going counterclockwise.
But you said the terminal could be at any point in the circle.
Yes,
right?
it's open. It's a hand, Rebecca. It's a hand. Just think about it. A clock
Yeah,
hand.
yeah, I know.
It's just that. That's all it is at this point. Terminal side.
So what about if you're going clockwise?
You don't. You go
You
counterclockwise.
only go
Stay there.
you only go
Stay
half-
with me on counterclockwise.
Okay.
The terminal side is also your hypotenuse.
Oh. Okay.
I'm gonna just put hypotenuse. So all it is think about, this is what you gotta think. We got a clock, right? We got one hand. That's where we at. We got a clock with one hand. This one hand is the terminal that's going
Wait,
around.
could it be
That's
the
going
hour,
around.
the hour hand or the minute?
Just one hand, Rebecca.
Okay,
No
okay,
matter if it's a
okay.
minute or hour.
Okay.
One hand on the clock. That's it. All right. So now that that point is done, if you look here, you can make a triangle within this circle. So let me try to show you what I mean. Do you see how I just made a triangle? You see the terminal side, which is your hypotenuse side. I'm going to bring this length down. Do you see my triangle? Right?
Wait, how did it become a triangle?
Because I'm taking you somewhere. So you gotta know, any point on this line here, going left and right, will be your A value. Up and down clearly will be your B value. Any point along this line, just like a regular coordinate, the A value goes here, the B value goes up and
Yeah, I
down.
wrote the A is X and the B is Y.
Yep,
Okay.
you got it.
Um,
Now, let's say I had a theta or a little x. Let's say I put me a little, I'll call it theta. Theta and x is the same thing. Instead of using x like we were doing algebra, we're gonna use theta. All right, this is the same thing. It's like me saying 3x, you know what I'm saying? So it's the same thing. Theta and x is the same thing. So, what do you notice? Here's your first coordinate. The x value, or the first coordinate that you have on here for A, think about it. If the terminal is 1 or the hypotenuse is 1, what could be the value of theta? What would I have to use? If I was using that, and remember theta is the x value. So you have to use this x line,
which is the A.
which will be what? Think about it. Which one of these, which is your A, you're right.
Wouldn't they all be one?
No, you stay with me, Becca, you're right. This is your x, right?
Yeah.
So what if I was going x over the hypotenuse? What would you call that? what would this line, if we were talking hypotenuse, opposite, adjacent, what would this line be right here? This would be my what to theta?
Wait, what are you finding?
Think about the three signs.
Yeah, I am.
If I had theta and this line here, what would this be to theta? This is really your what?
Adjacent.
Say it again?
Adjacent.
That's your adjacent sign,
Oh,
right?
to the-
So
to the
if I'm trying to find A, I would use adjacent over the terminal, which is the hypotenuse. What sign is that? Adjacent over hypotenuse.
Cosine.
Very good. So really your value of A, another way of writing A, how you got A and B, A value is cosine. Alright?
Whoa.
A value is cosine of theta.
Wait, what is it called? Beta?
Yeah, that's what we call
Can
it.
you
It's
spell
just
it?
like X. It's just, they call it a symbol. Instead of saying X, because you got
No,
too
but
many
wait,
X's.
what is it? FETA?
I don't know how about this
Oh.
stuff. I'm not worried about it. So, you understand that. You see how we made a little triangle, right? Theta would be, the value of A would be the cosine of theta, because you're going to be using the X value over the hypotenuse. Now, what if I needed the Y value? What if I needed the Y value? What would the theta be? What would the trig function for the Y value be?
Sine.
Because it's what?
Opposite.
Over the,
hypotenuse.
very good.
I'm lost.
Hold on, let me put it up there so you'll know. These are just like, this is like the, you know what this is like? Because y'all book readers. We just naming the characters. This is Bruce, he's like, da-da-da-da-da-da-da, and da-da-da-da-da-da. This is Rebecca, she's a farmer, she's da-da-da-da-da. This is all we doing, we just introducing the characters before we
No,
go
I
crazy.
didn't understand.
So let me run it back, we good. Now I'm gonna take you back to the beginning. Ready? Remember, this is, we already know this is X runs left and right, Y runs north and south.
So the X is the A and the B is the Y.
The X is the A, B is the Y, right? So we're gonna use theta. We made a small little triangle because we know that this terminal sign is like our
You said
radius.
that's like your X. The
Theta is like our X.
Yeah.
So to figure out these values of A and B, A, if I'm looking at cos of theta, this value that's running the line of A, this would be adjacent over the hypotenuse.
That's right.
Oh.
Yeah.
So the
Adjacent
B would be
over the
the B would
hypotenuse.
be the opposite, right?
B would be, because that would be opposite
Yes.
theta over hypotenuse. That's why B value is sine of theta.
Wait.
She was a stick
Sine-
shift, so I
sine
thought
is-
Sanji
hold on.
killed me.
Opposite over hypotenuse.
Yeah, I have to do it in my head. So dumb. Wait, but how would you do sine if you don't know what the opposite is?
We do. That's why we just made the theta. B is opposite of theta.
Yeah, but we don't know what B equals.
You don't have a value. That's what the Y is. Eventually, there's going to be a form. There's going to be a number there.
Okay.
So remember, sine opposite
Over
over hypotenuse. This was
Adjacent over
adjacent,
hypotenuse.
and then this is just opposite over adjacent.
Me fue la mierda,
All right.
la mierda.
Got me? So we now know that on the unit circle, the value of A is really just the sine of theta. The value of B, the value of A is just the cosine of theta. The value of the B coordinate is just the sine of theta.
Wait, is this always or just in this instance? Is it always like that or just in this example?
Always, always,
Oh.
always,
So
always.
you're always using cosine and sine?
Yep, those two, yeah.
So no tangent.
Well, we know if there was one, write this for yourself so that you know that I put it over here. Cosine of theta is going to be your X, and sine
Yeah, I got killed in that.
of theta is going to be your Y.
Y no, estábamos tres ahí.
Which one?
Si no es Melina, es Sanji. Si no es Melina, soy yo.
Got me?
Marico, pero es que me está gracioso, salía para salir.
Hello.
Got that
Mira
part?
cómo da Sanji.
Now, that's all I want. That's it for just that part. You now know the unit circle.
What?
That's the beginning part. That's the introduction. That's it. I know. And I'm gonna save this. Hold on. Now, Part 2, that was chapter 1. Chapter 2, we're now talking, you're gonna have to learn how to go between radians to degrees.
And degrees to radians.
Yeah, this is easy though. Degrees to radians.
I hope it's easy.
No, it's really easy, right? So go back to that unit circle. When we was talking, and we know we're going. So, what you should know is this is your X, this is always your starting point, right? So we always start here going which way? Counterclockwise, right? Going this way, right?
Yeah, I'm just
From this point to this point, Ruth, Becca,
Yeah, I'm listening.
this from 0 to 180 degrees, this is pi.
Wait, it goes in degrees? I thought it was units before.
It is pi. This is 1 pi. In other words, 180 degrees. In radians, this is 1 pi. Remember, radians is measured in pi. Degrees is in the center. This is the sign for pi. I mean for radians. This is your degrees.
How did you get 180
Because
degrees?
if I was to go, what's the
Oh,
measurement?
the semicircle.
Semicircle is how many degrees?
But how do you know that equals 1 pi? That's what
Because 2 pi's equals 360. 1 pi equals 180.
Oh no, this is.
So, I know, hold on, watch, it's not hard.
Do you have to memorize that?
So we'll do it this way. From start to halfway is 1 pi.
Yeah, that.
From here on, this is 2 pi. All right.
Okay, ya, Melina.
Eso que tienen acá.
Marico, que risa como lo vamos
So, starting at X, going this way,
A mí no me dio risa, que era el impostor. A mí me dio risa que me
I'm at what? From here to here is 1 pi.
No, I understand that part, but when you say 2 pi, I'm assuming you mean 2 of the 180 degrees.
Well, I mean, if I got 180 being
like
1
the
pi,
full circle.
if this is 1 pi,
No,
this-
I know that's what I'm saying, the full circle, right?
it's 2 pi.
Yes, yes.
So you know, what do we know in conclusion? Right here, we can put this down, that 2 pi's equal how many degrees?
360,
360 degrees.
like a year.
Yeah. Yeah.
Except the same.
So, and we also can tell that 1 pi is equal to
André,
180
ven acá,
degrees.
Jorge.
180 degrees. So, using this here, it's safe to say that 1 radian equals 180 degrees
Wait, are these formulas?
over pi. Yes, you're going to use this in a minute.
Wait, no, the 2 pi equals 360 and 1 pi equals
2
180.
pi equals 360. That's just the form, you know.
So those are
1
the-
pi equals 180.
So those are like the metrics.
There you go.
Okay.
So 1 radian equals 180 degrees over pi. This also means that a degree equals pi over 180.
Wait.
So to convert, if you want to go from radians to degrees, you'll have to divide 180 over the radian. You'll put whatever the radian is and divide it from 180 degrees over that radian. If you want to go from degrees to radian, you'll put whatever the degree is. You'll put whatever your degree is and you'll insert it. If you want to know if you go from degrees to radian, you'll put whatever you want in degrees and measure here. So here's an
This
example.
is 1 radian, that's from radian to degrees. Wait, no, degrees to, wait.
Yeah, to go from radians to degrees, you want to divide 100. You're going to put however many radians are here, set it equal to 180 over pi. Watch, I'm going to show you an example. For an example. I got, hold on.
It's neat, it's neat.
Oh, wait.
Es me, muchachos.
Who? Who is it?
Yo.
I think we might have briefly covered this with you.
Which one? Oh, not that. Oh.
So now, Becca, using this and Ruth, person love in there.
Yo entiendo.
Let's say I had 30 degrees.
No me ibas a matar, estaba detrás mío,
And I want to know how many radians is that?
Sancho, he tries to skip. I'm going to Sancho.
How many radians would 30 degrees be? So using this, are we going from radian to degrees or we got degrees, right? So we'll use this one because we need the radians. So you'll set it to 30 degrees equals pi over 180 degrees. With me?
So it's degrees to radian?
Yeah, we're going from degree to radian first time. Then I'm gonna show you how to go from radian to degrees.
Okay.
Hey, ma.
With me?
You know who it is,
I
right?
know who it is. It's the yellow one.
One
Who's the yellow
second,
person?
sorry, I'm just waiting.
Who's the yellow person?
Bro,
Melina? It's Melina, bro.
Wait,
She pretending to do a task.
It's married.
She took like 5 seconds for something that takes 1 second. She pretending. It's
Yo sé quién es.
Ah, no sé, ya no sé.
this one, Melina. Thank
Yo
you.
estoy muerto. Yo sé quién es.
Yo, una marica.
Esa malita.
Wait, what did you write on the top? 30 degrees equals question mark?
Yeah. 30 degrees equals how many radians? This is the symbol for radians. So you set it up. 30 degrees equals pi or radian over degree.
Yeah.
Then we just multiply. I got it.
Hold on. What was 30 degrees over 1?
Yeah. So what happens? What's going to cancel?
Are you cross multiplying?
Okay, so what's going to cancel?
No, I'm asking, are you
No,
cross
we are. We're multiplying across.
Oh,
What
it's
cancels? What cancels? The degrees cancel. These cancel. So now you end up with
30 pi? Or radian, sorry. Wait, is it pi? Wait, would you still call that pi?
30 radians
Oh.
over 180, which we simplify down to what?
Pi over 6.
What?
1 pi over 60.
I was gonna ask if you
Someone
keep
press the
this
button.
in.
It's
That's
red.
your answer.
Él dice que es rojo.
So to go from degree to radian, just put set the degrees, set it equal to the radian.
It's the red one. Who's the red one?
Mato,
Who's the red
mato.
one?
Now, if I want to go from radian to degrees, let's say we were going, what would 3 radians
She
be?
didn't do it. She was standing there.
No, yo lo estaba poniendo, pero es que como que no tengo una verga cómo lo pongo.
She's a liar, bro. She's lying. I saw that. I'm waiting for my mentirosa.
What cancels?
Qué maldito que no voy a más.
The radian.
The radians would cancel.
Wait, it's called radians?
Radians,
Radian.
1 radian, 2 radians. So the pi's cancel.
So it would be 3 equals 180 degrees.
3 times what?
180. Wait, huh? I'm confused.
¿Qué voy a hacer? No, no tengo que
What do you mean?
Ahora sí, hermano.
Es macho, weón.
That's right. Think about it.
So we're gonna try now.
Think about it. What's 3 times 180?
540.
Ah, mira cómo lo hace la verdad.
I think the calculator.
540.
Degrees. Oh wait, no, wait,
I'm sorry, degrees. You're right. 540 degrees.
That's what I was confused. I was like, why is that supposed to be?
Because these cancel, so we just add degrees. Think about it. Go back to your circle, right? If from, I want y'all to see it. 3 radians is 540. Think about it. If 1 radian is from here to here, that's what? 180. 2 radians is from here to here, that's a perfect circle 3. Then the 3rd radian will have to come back here. So that's 360 plus another 180, and that's how we get our 540.
Oh.
3 times around, you went from here to one more time. Got that?
Yeah.
Boom. That's the notes. That's it. So now, boom, that's part 1. Now we're gonna go into trying
You said
to.
this was part 2.
I mean, part 3 is because now we're gonna start solving. I can click that. We got the notes down. That's the most toughest part.
Wait,
Now.
we have to do it today?
No,
Because nobody else is paying attention.
Yeah.